Hi everyone, I'm Chanakya Gajrapu. My background is in information technology and security focused app development. For this hackathon, I worked as a lead architect and an ML integrator, making sure the system runs fully on device with Python ML through Chekobi.
Hi, I'm Vikrant. I worked in the field of mobile development, applied AI, and backend systems. And my role was to handle mobile implementation, system integration, and ensuring agents work together seamlessly and real time together while building the on device multi agent system.
So, talking about the problem statement we have here, currently fraud is rising at an alarming rate in 2024 as per the service. Consumers worldwide lost over 12.5 billion to fraud. That's a 25% increase in just 1 year. And in India alone, online scams drained nearly 4,245 crores in just 10 months. Now, this is challenging. The fraudsters are getting smarter and blending with the genuine user behavior, which makes it incredibly hard for current systems to catch them quickly without also punishing the real users.
And when is no one trying to solve these problems? Yes, of course. But the bigger issue is users expect privacy. They don't want their personal data to shift off to cloud every time they log in or they buy something. But most fraud detection tools do exactly that, sending sensitive data to cloud, relying on rigid rules and outdated models. This leads to risks and huge false positive. In fact, false positive cost merchants more around 443 billion each year, way more than fraud itself. On top of this, new fraud schemes appear faster than companies can update their systems. So business are always a step behind.
So that's where our solution comes in. OddMass, which is on-device multi-agent security, our application, instead of sending data to the cloud, our system continuously learns the unique way you use your device. Your touch dynamics, typing rhythm, even app usage style, and flags anomalies instantly, all while staying completely on device.
What makes us unique? No cloud, zero data leak, privacy by design, all computations from fast statistics to deep learning to assemble ML happen on phone itself. It's secure, it's private, and it's adaptive.
Now, moving forward, how are we different? As my friend Vikrant already told you, people are trying to do this already, but not in the best case scenario. So here, we made this completely on device, which means no internet permission at all local and encrypted on your device. Now, this is going to help you by your data not leaking to anyone so that they can redo the same thing. OddMass, on-device multi-agent system, a privacy-first architecture for advanced behavior biometrics. Our system is 100% on-device with no cloud dependencies and no internet permission required. This means no behavioral data ever leaves the phone. This exceeds GDPR and CCPA compliances and gives the user full control, including the ability to delete data and reset models anytime. Despite this, the footprint is light, around 50 MB memory and less than 2% extra battery use. OddMass uses a multi-agent system with specialized agents working together. The Tie0 agent runs fast statistical checks using Mahalanobis distance, responding in under 10 milliseconds. The T1 agent uses autoencoders for deep learning, analyzing patterns in under 100 ms, while the Chekobi ML agent runs Python ML, resembling it under 200 ms. All of these are coordinated by the Fusion agent, which blends results and policy agents, which decides when to escalate or trigger biometrics. The fusion model is the core of our confidence-based fusion model. If the Chekobi ML assemble is over 80% confident, we blend its score with the others. Otherwise, we rely more on the Tie0 and Tie1 agents. The adaptive weighting helps minimize false positives while ensuring fast, reliable, and fraud detection agent. Now, talking about the activity attributes and performance, the system delivers over 95% accuracy as per testing in detecting behavior anomalies. With sub 200 ms response time and around 99.9% reliability, it runs invisibly in the background, with linear scaling as more devices adopt it, and adds virtually no description to users' workflow.
When coming to architecture components, data flow from touch input to feature extraction, which generates 10 behavioral inputs like pressure, velocity, dwell time, flight time, and curvature. Thus go through the multi-agent analysis, then fusion, and finally into the policy agent, which manages the trust, credits, biometric prompts. Core components include the security manager for orchestration and baseline storage for encrypted user data, and foreground services for continuous monitoring. And coming to accuracy and edge outputs. In real world, Oddmas achieves 95% plus detection accuracy with less than 5% false positives and less than 3% of false negatives. It produces continuous risk scores from 0% to 100%, uses trust credit system to avoid excessive prompts, and escalates at thresholds like 60% medium, 75% high, 85% critical, and all thus runs under 5% CPU load and a 2% battery impact. When looking at the business impacts, the behavioral biometrics market is projected to hit $7.2 billion, growing at over 23% CAGR. With Oddmas, we estimate a huge potential revenue if integrated into ecosystems like Samsung Knox and Galaxy platforms. Our approach offers a 2 to 3 years technological lead, combining superior accuracy and full privacy with low resources use and using high edge in the market. The final takeaways. To summarize, Oddmas is 100% on device, ensuring maximum privacy. Its multi-agent system delivers both speed and accuracy. With its lightweight footprint, it integrates perfectly into security-focused ecosystem, positioning us as leaders in behavior biometric spaces.
Okay, so I'll explain you how the Oddmas application works. Usually, since we are using and since we're talking to the OS, we are supposed to give them few permissions which is needed by the application. And once that's done, it's going to prompt you to do a basic calibration test for the first time, since it has never done this before. So let me try doing the calibration. Here it's asking me to go back to the main screen and try doing basic things like swiping, scrolling, or basically tapping anything. So let me do that. So I'll try going into some website, browsing through it, like the way I usually do. Clicks, swipes, going back, going up, and things like this is what is needed for the sake of touch calibration. Let me open the app again. Okay, as you can see, the touch calibration is done, and it's asking me to do a type calibration. For this, it's asking me to type the sentence which it gave me. Let me try to do it. Okay, so as you saw, the touch calibration is also done. Now I'm just supposed to click on the complete calibration toggle. Once it's done, it's going to work in the background with the machine learning to get that thing done. As you can see here in the Python ML, this is where the background task is happening. Okay, so now that it's done, I use this like a normal user right now. So now let me try to do a bot behavior or any other user behavior. I'm clicking on test for the sake of demonstration so it can start doing it. Generally, we are supposed to leave this for at least few hours for the sake of calibrating properly, but for the sake of demonstration, we implemented this test feature where it simply uses the baseline which I gave it right now. Okay, now I'll try to use like a bot or someone who is not me. As you can see here, I'm trying to just act as if I'm not me because all these touch patterns are not mine. Soon it's going to tell, oh yeah, there you go. So since it understood that it's not me, it's asking me to do a biometric authorization to understand if it's really me. And once I do it, it's going to reevaluate the risk and understand that this kind of behavior is also the user's behavior and also learns it using the machine learning. And this is the adaptive learning which we're talking about previously in our presentation. So this is our application. As you can see, the agents in here, the T0 agent, the T1 agent, as we said before, the fusion combines both of them, and as per the policy control, it's going to give you the risk factor. If the ML is not completely trained yet, it's going to solely work with the T0 and T1 models as of now. And the credits are and these credits mean if any of the three agents are not working as they're intended to, it's going to decrease the number. For now, the credits went down to 1 by 3 because maybe the touch or the type patterns are not as usual. So this is our application, and thank you.
Thanks again for sticking with us until the end. To recap briefly, every year we see 12.5 billion lost globally to fraud, a sharp 25% surge just in past 1 year alone. Traditional detection systems, often reliant on cloud-based rules, cannot keep the pace, create false positive, and hurt the real users. That's why our on-device multi-agent systems shines, and it brings the real-time fraud defense directly into the user's device. No cloud, no data sharing, just faster response that respect privacy and reduce user logouts. Our multi-agent system, smart fusion logic, and trust credit policy make it not just accurate but practical and user-friendly. While remembering the impact, end users get seamless and private protection, which is a core objective. And when it comes to business, it cuts billions in fraud and false alarms. Security teams access an adaptive, scalable solution that evolves with fraud tactics. Regulators and privacy advocates see a solution that's ethical and fully compliant. Investors can get into booming markets. Current estimates show that global fraud detection prevention industry is rapidly growing between 33 billion USD in 2024 to over 90 billion by 2030. On-device multi-agent system stands strong out, being fast, accurate, ethical, and ready to scale.
That being said, we genuinely believe this is more than just an idea. It's timely, real-world solution to an escalating crisis. So we are excited to take this forward and hope you see it as a potential use too. Thank you so much, and we would love your feedback and support for the next round.